Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at doing some 3D graphing and looking at that from algebra through calculus. My name is Mike Houston, and I'm a moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight I'm excited to be joined by our panelist, Steve Phelps. Steve's an instructional technology consultant with the Hamilton County Educational Service Center near Cincinnati. And Steve is a T-Cubed national instructor and co-author of the Advanced Quantitative Reasoning, Mathematics for the World Around Us, which presents quantitative literacy, statistics, and modeling as an alternative to the traditional high school senior math courses. Steve, it's great to have you with us tonight.
Thanks, everyone. I'm excited to be here.
We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Steve using the Q&A window on the right side of your screen. And we'll also be using the chat window tonight to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the very top of the WebEx menu and choose Audio Broadcast. At this point, Steve is going to discuss our agenda.
Oh, my. Well, thanks for coming, kids. So our agenda, I think we're right in the middle of welcome and introduction. So let's go on to the second bullet point. So 3D graphing with Nspire technology. So I want to make sure that I said in the title that we'll do everything from algebra through calculus. So along the ways, we'll do a little bit with cross-section of solids, graphs of planes, and not only planes, but also different surfaces. And we'll also talk about some solids of revolutions at the end for the calculus class, but I'll kind of go in an order. And I would like to say that all of these are classroom tested. And at the end, there's going to be a webinar drawing. I think Mike is going to do that, I'm assuming. But,
I sure am. Thanks, Steve. I know Steve and I talked prior to the start of the webinar, and he thought that it might be a good idea if you have a TI-Nspire on hand to go ahead and grab it. He's going to try and go at a decent pace where you'll be able to follow along step by step with him. But just a word of caution: if you don't either have an Nspire with you, or you don't feel super comfortable maybe using your Nspire, or you start maybe falling behind a little bit, don't worry about it. Just put your Nspire down and then just hang tight and just watch and follow along with Steve and interact with Steve. You'll automatically get a follow-up email in a couple days with a link to the recording of this webinar, and that might be the best way to experience this with your Nspire. Steve, I'm going to give you control, and it'll be your show.
Oh, man, here we go. Here we go. Okay, I'm just going to share my screen. I think it's going to be easiest to do. Oh, my gosh, look at all that. Oh, my gosh, look at all that. So let me, I am nowhere in the correct spot. Certainly not prepared. Now I'm prepared. So, so again, 3D graphing on Nspire from algebra through calculus. So I'm going to do my best to kind of address how you could incorporate the Nspire's 3D graphing capability into all of these classes. Now, a little bit about webinar etiquette. And man, that's a fancy word for me. So I like to use the magic word. And so from time to time, I will ask you to respond in the, I guess there's a chat window or a Q&A window, and I don't even know what window will pop up on my screen. So I've got like a chat window. And so from time to time, I will ask you to maybe respond there. And so to respect everyone's thinking time, is I would respectfully kind of request that no one responds until the magic word is uttered. And so typically that'll be a couple of seconds or half of 30 seconds or whatever, but the magic word for tonight is Pafnudi. So let's practice. Let's practice. If you could put your answer into the chat window, what I would do is I would type my answer into the chat window, but don't send it or press enter until I say the magic word. And then what should happen is I should see all of these responses come flying through. But this way you are respecting everyone else's kind of thinking time. So have you used a 3D grapher on the Nspire before? And if so, how often do you use it? And just enter your answer in the chat, but don't send it until I say the magic word. And in 5, 4, 3, 2, 1, Pafnudi. Whoa, man, I just freaked myself out when I saw all those messages. Then I want to say, oh, use a little bit, not much. No, if not, that's okay. That's okay. A little bit, not as often as you like. You guys did so well with that. You did so well. So that's how I like to do that, and I'll try to do that from time to time, and we'll go from there. So a couple of things. So if you are wanting to play along at home and try this on your 3D grapher, there's a couple of things that we probably need to do first. Is to set it to get to the 3D grapher, you want to go ahead and create a new document, or if you have a document open, that's fine, use that. And then to add a 3D grapher or a 3D graphing page, you need to start by just adding a graphing page. So I've always done it with my students. I just go Control Doc and then press 2 to get that graphing page going. And then from the graphing page, what I'd like to do is I'd like to go to the menu and select View. And from View, I will go to 3D graphing. So for example, on this page, I'm going to go ahead and insert another problem. I'm going to insert a graphing page. And this is your normal 2D graphing page, but under the menu window is you go to the view, which is number 2. And then your third choice is the 3D grapher. And by default, it comes up as Z equals. So it's a Z variable equals something with an X and Y in it. And it doesn't need to have an X or Y, but if you're going to use variables, it must be those two, but it doesn't need to have both. And later on, we'll change this to parametrics for some things. But most of the things that I would do in an algebra class or even an algebra 2 class would almost typically just involve using this window here. A couple of things. So if I look at this box, and I will go back to the box for a second. Let me go back to my box. And this box, let me escape that. Ooh, it looks cubish. So in the chat window, don't type your answer in. Type your answer in, but don't press enter and send it. But in the chat window, what are the dimensions of this viewing box that I'm looking at right here? So go ahead and type in. Type in, but don't send it. So I want the dimensions of the viewing box, and the magic word is Pafnudi. Oh, yes, 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 yes. Most of my students are probably going to say it's a 5 by 5 by 5 box, which is not entirely correct because it's going to go 10 by 10 by 10. But it is a cube, so that is something that we can work with. And again, I'm just dragging that cube around with my mouse. I could also on the keypad, I can click and rotate like that. I can also click up to tilt it up, or click down to tilt it down. And if you come to my session at the International Conference in March, you can see all this stuff again, and maybe I'll bring cookies. Now, sometimes this can be really, really tough to do, to click this little clicker back and forth and up and down. So sometimes you can just press A on your keypad. So if I go down there to where the letters are and I just click the letter A is automatically rotating. So automatically rotating, and oh my gosh, if I wanted to stop it, maybe I could press escape to stop it. Now here's the thing though, A automatically rotates it. Escape is like my stop button. But what I need is now it's all out of whack, and I don't know like how to get it back. So what I want to do is I want to restore the original orientation, and so that is the O button. So if I click on the O button, that will restore the original orientation of my graphing window. So A does an automatic rotate. I can click on the touchpad and go up or down, left or right, and then escape will kind of stop that automatic rotating. And there's some other things that we can also do. So, for example, if you go, I think I did, I'm used to it on my keypad. I like to go control on my keypad on my desktop is control greater than. We'll talk about where those things are. But here's all the shortcuts. If I go to my menu, I have all of my shortcuts here. And this is where I can rotate, where R is rotate, but you can just click and auto rotate. And zoom is either times or multiply without times or multiply. Magnifying your box is by timesing, and then shrinking the box, zooming out is division. So without pressing control, if I just go times, my box gets larger. If I press divide, the box gets smaller. And so again, those are some of my favorite features to use. And we may do one more thing. I think we've kind of hit all of those high points. And so some useful graphing shortcuts. So while we're here, let's go ahead and graph a function that this is a function I like to use with my algebra students. And so to get the graphing window back, you can press the Tab key on your handheld. And what I'd like to do is I'd like to type in z equals, but z is already there, so I'm just going to type in x squared plus y. And so x squared plus y. And once you've typed that in, go ahead and press enter on your keypad. Now we have this. Oh man, this shape is awesome. This shape is awesome. It's like part parabola, part, is it a hot dog bun or is it a taco? I don't know what it is. So some very useful keyboard shortcuts. If you press on your letters at the bottom, if you press X on your letters, what that does is that actually looks down the positive X-axis at the object that you've graphed. And so this was one of the things I used to always do with my Algebra 1 kids, when I would get these kids from 8th grade. So my Algebra 1 kids is probably more of an advanced Algebra 1. In 8th grade, they had Algebra 1, but they, for whatever reason, weren't good enough to get into honors math as freshmen. So they got to do algebra kind of a 1.5 with me. And 3D graphing is one of the first things I did with the students every year. So I tried to make the connections to, it's just a natural extension to 2D. And I think kids can handle it. They live in a 3D world, so I think they can handle it. So I used to love doing this like here and try to explain why do we see what we see. If I press the Y button, now I'm looking straight down the Y-axis, and so now I get these like kind of like parabolas. They look like parabolas, and I get this big parabola, kind of a an outline there, which is kind of, why do I see that? And if I press Z, I look straight down the Z-axis from above. So I'm looking straight down at this from the top. And again, the question is, why am I seeing what it is that I'm seeing? And if I want to restore the orientation again, that letter is O. So if you press O, you restore the original orientation. So those are most of the shortcuts that I think we need. Oh, I do need to show you color. I do need to show you color. So let me go back to color. I will go back to color. I'm using my slides deck as kind of like a reminder, kind of like my lesson plan. So if I click on the object that I want to change the color of, and then click on it, Control menu. That's kind of like my right click. And I go to number 5. And I can change fill color. I think I have my background color by mistake. And I can change my background color. So I click on the surface again. And I had my background color by mistake is what I was doing there. Oh, let me escape. So there's my context window. If I go down to color and do my custom color plot, and I can change, for example, the top of my surface, I could change it to red. The bottom of the surface, I could, for example, change to blue. Or if I go back to colors, I go to custom plot again. I can color by height or color by steepness. If I change the color by height, that color, this is what my kids love doing this, just changing the colors of things. They actually like making the background black. Or if you can change your color, instead of by height, you can vary by steepness. Gives you a little bit different color as well. I think that is pretty good there. That is about, those are the colors, and we'll have those colors in there as well. So let's talk about some 3D graphing ideas for Algebra 1. Some 3D graphing ideas for Algebra 1. So again, my kids came in with a really good understanding of linear things. And so I like to try to jump right in with planes, and we'll actually see something when we talk about geometry. We'll actually see one of the very first activities I used to do with my students, which involved cross sections of a cube. But again, one of the things that you can do is that if they can graph planes and they can visually see what the solution to a system might be, where those 3 planes intersected at a point. So again, any equation where you can kind of write it for algebra students, I mean, this is not much different from slope-intercept form, from going y equals mx plus b. Now we're just doing two variables, and the z is how kind of far above the floor you are. But if they can understand what this graphing is doing, then you're not very far away from something kind of whimsical like the monkey saddle. And so the monkey saddle, I will find my monkey saddle for you. There's my monkey saddle. So it's it's literally called a monkey saddle because the legs would kind of go over the two sides and the monkey's tail would go down the back. And this is one of those things where, I mean, you could try to discuss and talk with kids about, you know, why does it have this shape? What is it about the equation that gives it this shape? But if you press the X, Y, and Z buttons, this is what it looks like looking down the X-axis, and what it looks like looking down the Y-axis, and what it looks like looking down the Z-axis. So these are totally kind of unexpected types of views that kids might see. And in particular, the Y-axis, this would be something, for example, in an Algebra 2. I will show the equation again. And so my equation is slightly different, but this is the equation that I am graphing in my Nspire. That kind of flattens it out a little bit. So the typical monkey saddle is x cubed minus x times y squared. But what I did is I multiplied through by, or divided through by 10. It just made it fit a little better in my screen. You're welcome. But I'm thinking in an Algebra 2 class, each of these little curves I kind of see, it appears to be like vertical lines or cubic curves. So I could do the same thing in an Algebra 2 class. So again, the monkey saddle is one of those, you know, there are lots of whimsical things. And if you just search for them in like Wikipedia or on Math World, you'll find them. So, I mean, you can find the equations of these surfaces and they exist out there. And so why not give your kids a chance to graph them and try to make sense of them and why they work this way? And then again, as I went back in Algebra 1, and we would try to explain with my kids, because my kids were pretty good at graphing, as I said, and they had seen equations of quadratics. And so this x squared part in this first function that we had originally was not brand new to them. But we would look down different axes and try to explain why we saw what we saw. So I think overall, again, my students in Algebra 1 were probably a little bit more advanced than your typical Algebra 1 students, but I think it gave them a little better understanding of what it meant to graph, and especially what it meant to graph in 3D, and I think it kind of taxed their spatial skills. I really think that this is a kind of a good thing for Algebra 1 students to kind of start to understand graphings of functions. And I think trying to lay a groundwork down the road for maybe possibly getting to calculus, at least when they get to college. And so some graphing ideas for geometry. This is, of course, this is one of the first things that I did. If this was not in day one, it was in my first week with my students, because I wanted to give them an entirely different experience. My Algebra 1 students, by the way, but this is something that they could do in geometry. And so I'm talking about cross sections of a cube. And so to show you how this looks, I'll go back to my Nspire. And so here is an example, and I will show you the equation. So what I've done is I've graphed an equation, and I tab. When I tab, I have to toggle back up to get to the equation, and I graphed. And so what I graphed to create this what looks like an equilateral triangle is I graphed x plus y plus 5. And so that gives me this. It is an equilateral triangle. I think students in geometry could probably make the argument that this is an equilateral triangle early on. But I've seen this proof, that students have been asked to prove this in geometry, and make an argument that the diagonals of the square faces are all the same. But certainly that's a common, like a contest problem that you would see. But what I'd like to do with my algebra students also is instead of a plus 5 at the end of that equation, what would happen if I made that a plus 2, for example? And if you plus 2, how can you explain what is happening here? Well, the plus 2, it's similar to kind of your slope or your y-intercept in slope-intercept form. I went from plus 5 to plus 2, so now I've moved down the axis, the z-axis, from 5 to 2. And so for geometry students and Algebra 1 students as well, I think there are 11 different cross-sections you can get by changing the different types of variables, or the parameters, not variables, parameters. So if I toggle back up, maybe instead of x, I could go x plus 2y. And I will make that just a plus 0 at the end. And so I think we can make the argument that this might be a rhombus. So could we get if we can get a rhombus, could we get a parallelogram? So those are all the types of questions that I'd like to ask my students if we could do that. But again, this is an open-ended, and this is one of the first things I did in the first week with my Algebra 1 students, those kids that are kind of between Algebra 1 and didn't make the cut into Algebra 2. Another thing which I don't have on this one, but it is on the file that I believe Mike will send out. So if you can create an equilateral triangle, then you're just around the corner from creating a tetrahedron. And so it's simply by making small changes to the equation x plus y plus 5, which gave you that original equilateral triangle. A fantastic geometry exercise is to try to make this solid. And again, this works out well. These planes actually go infinitely far in all of the directions, but since they're being clipped or cut by that viewing box, it creates the illusion of triangular face. Oh my gosh, Mike, that came and went so fast. You know, I think the 5 probably in this case does. So if I change my Windows settings from -10 to 10, to get the same figure, I'd probably want to go plus 10. But yeah, that plus 5 is a thing, but I'm not going to tell my kids that. I'll let them figure that stuff out. Laurie, can you graph a line in 3D? Yes, I will show you how to graph a line in 3D. I will show you how to do that. When we get to more of the calculus things and Algebra 2 things, you can graph a line in 3D. Sorry, I missed that question before. And so if you can create a tetrahedron, then you can also create a stellated octahedron by just, again, changing the symmetry in the equations is what's stunning to me. At the x plus y plus 5, if you kind of figure out all the different ways you could have pluses and minuses in that equation, you end up with this shape here, which is a cool shape. I think it's cool. You might not think it's cool, but I think it's cool. But again, I think it's a nice geometry thing. And again, it's the illusion. I would love to get an octagon. I've tried to do a couple of those things. I need to keep tinkering with that a little bit more. But maybe I'll have a solution to that by the time the TQ comes around. Now let's talk about ways you could use a 3D graphing in Algebra 2 and pre-calculus. From my point of view, I think what this does is this is the transition point, maybe where instead of writing equations kind of as in a linear form, we're going to use more of a function form. We're going to use a parametric mode or a parametric form. And this is, I think Laurie was asked about graphing a line in 3D. And then to graph a line in 3D, we probably need to use parametric form for that. But I think we can talk about how to set it up into parametric form. But there are a number, again, if you can find the equation online, the parametric representation of a surface, you can graph it. You can graph it. That's the most awesome thing of all. And so the question, do I start students with paper and pencil 3D graphing before using calculators? And no, I did not do that. And I actually probably started to switch more towards the end. Is I probably started doing more with tech first, and then trying to take it to paper afterwards. only because I had some motivation that you're probably going to do this on paper when you get to some sort of a test. But yeah, no, I did not. I went right into 3D graphing so they could see what the heck was going to happen. So so again, if you can find the equations online, you can graph these things. So a helicoid is really kind of cool. So if you take a segment and put one endpoint on the z-axis, and as that point moves up the z-axis, have a segment that kind of swings around the z-axis as it moves up, you end up with this helicoid, which is kind of cool. It's actually a screw shape, as you'd see with a screw. Again, pretty powerful. But I think it's the parametric equations, which is something I think Algebra 2 and pre-calculus kids should see. Another one, which is the hyperboloid of one sheet. Well, we see these hyperbolic sines and cosines on our calculator, but really don't know what the heck can I use them for. Well, here is a use for the hyperbolic sines and cosines. And again, I've just given you a hyperboloid of one sheet, but the same idea would work for a hyperboloid of two sheets. And again, this is a very base equation, but you could change some other parameters and maybe change like a number, like multiply the x coordinate by 2 and the y coordinate by 3 and see what happens. Again, the Mobius strip. So, and this has been colored by, I believe, steepness. Blue is kind of cool color, so that's a steepness that's not very steep, it's a 0. And then red is more of a steeper side, that's kind of a hot color. And so again, you can, if you search for Mobius strip, you can find the parametric equations of the Mobius strip, and you can graph it in the Nspire. And if you explore the TNS file that Mike will send out later, there's a couple of other bells and whistles to that. And again, if you start to explore this and you have questions about this, you can feel free to shoot me an email about that. And again, the torus, which is kind of related in my mind to a sphere, but I did not include a sphere here, but I did include a sphere, I think, in the webinar document. Big R is the radius, like the radius of the tube, and little r, I should say, it's the radius from the tube from the center, and the little r is the actual radius of the tube. But this in of itself, if I guess it would probably be pre-calculus when you started to see, for example, when you began to see the unit, the trig circle, like that, you'd start to write the equation of a circle using cosine of t, sine of t. I think once your pre-calculus kids get to something like that, they can begin to make sense of why this equation works. Why does this equation produce a torus? So, I have so much trouble. I really can't tell the shape apart from a coffee mug. And that is that's called a torus joke. So let's see, there was a question that popped up there. I'm trying to plug in the equations, and I get an error message that the variable is in use. I'm using t and u. So my only thing is make sure you're in parametric. If you're using t's and u's, make sure you're in parametric mode. Let's set your calculator up into parametric mode now. And so, so I'm going to go back to my screen, and I'm going to go. So I'm going to add a. You are in parametric mode, so let's take a gander at this. So I'm going to go ahead and add a new problem. I'm going to add a graph, and I'm going to go menu. I want to change my view to the 3D graphing. Then I want to go menu again, and I want to change my entry edit to parametric. And so Laurie, I believe, asked about graphing a line. And so I don't need to use U's. I could just get away with T's. So if I did that as a T, and that as a T, and that as a T, and if I pressed enter, because my settings already have some limited values of T, I kind of have a line that goes from the origin up to the upper corner of that box, which makes sense. I'll show you where that comes from. And so if I, once I'm in this little graphing area, if I press my tab button again, it goes over to where those, someone called that something the other day. I wish I could remember. But if I click on the parameters, this is where I can change the values of t and u. And so right now my t typically goes from, by default, from 0 to 2 pi, and my u goes from 0 to pi, only because it's thinking you're going to do something with angles. But so you could change, again, you could certainly change this, so I could make that a 2t, I could make this a t minus 1, I could make this I'll just leave it as a t, and if I graph this, now I get a slightly different equation that does not go through the origin because 0, 0, 0 would not have been a solution. So you can graph lines in here, and I think that's probably a pretty good Algebra 2 thing, or if that's done in pre-calculus. I've kind of strayed away from doing that parametrics with my Algebra 1 kids only because I think that would probably have been a little bit of a leap for them. So, and again, so those are the things I think that in Algebra 2, if you can find the parametric representation of the surface, you can graph it. That's I think the biggest thing. And then most of these things tend to involve sines and cosines. And when you start to run across expressing circles in parametric form using sines and cosines, now you're at a point where kids can start stretching their knowledge, or kind of taking their knowledge kind of around the corner, because they're right there. They're right there at it. So just give them a chance to kind of work with this and stretch it and think about it a different way. I know it's not on their test, but it is in the math. So hopefully we would do that. And so let's talk a little bit about some 3D graphing ideas in calculus. And I did not include like surfaces that have square cross sections. If you come to my session in Dallas, we will address that in the session, how to create a solid with a given cross section, how to create those surfaces, because it's not terribly difficult. And again, I have done all of these things, or variations of these things, with all of my students. Including my students that were non-AP calculus students. So especially all of these things here. So let's go ahead. We can take a parabola, and we could rotate a parabola around the x-axis, or we could rotate a parabola around the y-axis. And let me show you how to set those objects up. And then that'll probably take us to close to our time. I think Mike, if I recall, do I need to be done by 10 till?
Yeah, that'd be fine. A little bit after or two, if you have anything else you want to stretch in there.
Ooh, so I can go to 9:15. Is that what you're saying? I'm just kidding. Just kidding. Just kidding. All right. So let me go ahead, and I'm going to insert a new problem up here. And I apologize for using my software like this, but it works easily. And I'm just going to go ahead and I'm going to add a calculator page right now at the beginning. And I'm just going to define my parabola. And so I'm going to go ahead, I'm going to call it f of x. And I'm going to use that. And just for kicks, I'm going to go negative. I'll go x minus 1 and to x minus 5. And then I'm going to go ahead and restrict my domain. So I'll go control. It is, so was that a question or a comment? But yeah, I could have gone the control, that little button right there next to the 9 will give me the define. But it has to be a define. It has to be the colon equal. It can't just be equal. And then I'm going to go ahead and restrict my domain. So I'll use my little domain restrictor, and I will go from -1 is less than or equal to x is less than or equal to 5. And again, I'm doing a terrible job. I'm doing it all on my keypad on my laptop. And then I'll go ahead and press enter, and so that is taken for me. So I'm going to use this function, this parabola, and I'm going to rotate this around my x-axis. I'll rotate it around the y-axis as well. So what I'm going to do next is I'm going to go ahead and I want to insert a graphing page. So I'm going to go Control Doc. And then I'm going to press 2. And I need to change this to a 3D grapher. So I'm going to go Menu, and I'm going to change the view to 3D. So I like that, how it's view is 2 and 3D is 3. And I want to change it to 3D in a way, which kind of helps me remember that. So I'm going to click on 3. And then what I want to do next is I want to take the I want to take my entry and I want to change it to parametric. So I'll do Menu again, and then I want to go to 3 for the 3D graph entry and edit. I want to change that to parametrics. And so what I'd like to do just to begin with is correct. That is correct. So if I go Control, that little button next to the 9 right above it. I'm just going to graph the parabola laying down in the XY plane. So in my X, I'm going to put T, and in the Y, I'm going to put F of T. And in my Z, I'm going to put 0. But what I want to do is I'm going to tab over because I want to open up the parameters, and I want to make sure that my T min, I want T min to be set at 1, and I want my T max to be set at 5. And my U min and max don't matter right now, but they will shortly, but right now they don't matter. I will click on OK, and I'll tab back over into my equation, and I'll press Enter. Syntax error. No. Let me put a U there and see if it times U and see if it does that. I was having trouble with this before. Good there. No, that's interesting. Why is there a syntax error? Perfect. T. Oh, got it. Yeah, I know. Of T and 0. Yeah, I guess I broke the Nspire. I guess that's what I did. I must have broken the Nspire. Interesting. Plus 0 times U. I'm going to see if I have to just, if it's wanting me to put in a U. Zero times T plus 0 times U. Well, that's certainly nuts, kids. That's nuts. I wonder if this is related to the problem that was Josh had before with the variables in use. Because, interesting. So let me do this. Let me open up a new document and see if I can make it work in a new document. Yeah, that's weird. Maybe there's some tech people here who see this happening, and we can pay attention to this. Let's see. So let me change the view to, so Mike now have no problem going until 10 till. And so let me change the view to 3D, and let me change my entry to parametrics. Perfect. And let me insert a calculator page just for kicks. I could have done this in a graphing page, but and then here is the control define button. negative x minus 1, x minus 5. And I won't restrict the domain here. That might be. I wonder if that's what it doesn't like. And let me go back. T, f of t, and 0. I'll go over here and I'll change that from 1, 5. And so, okay, so I created a new document and there it works. Now, if we want to rotate this around the x-axis, if I look down the x-axis, what I would expect to see is a bunch of circles. So in other words, it seems like my circles would be something like a y-coordinate times cosine of an angle and a z-coordinate times a cosine of an angle. So what I'm going to do is I'm going to go ahead and press tab and open this up. I'm going to leave my x as t, but then in my y, I'm going to go f of t times cosine of u. And then in my z-coordinate, I will do f of t times sine of u. And I'm going to tab over to my those 3 dots where my parameters are, and I just want to make sure that see, my t kind of always goes back to default. I want my t to go from 1 to 5, and I want my u min to be 0, but I want my u max to be 2 pi. So I'll put in a 2 in front of there. And I won't have time to add a slider for this, but we'll add sliders to this to actually animate the revolution around the x-axis. We'll add a slider to that at the T-Cube conference. So if I press enter, there we go. And so that turned out pretty nice. And since Mike said I could go a little bit after 10 till, I'm going to go ahead and take us around the y-axis. Now I'm going to hide this. So I'm going to toggle up and uncheck it so it hides for me, please. And then what I'm going to do is I'm going to go back to my graph, and I'm going to look down the y-axis this time, and what would I see? So if I'm looking down the y-axis, which is what I'm rotating around, I would see a whole bunch of circles. And so the circles would be based on the x-axis and the z-axis. So it seems like my x-axis is going to be something times a cosine. My z values would be something times sine. So I'll reorient it, press tab, and I'm going to press t times cosine of u in my x entry. My y entry is just f of t because I'm not really changing how far out the y-axis I'm going. And my z-axis is t times sine of t. And let me tab over to the parameters. I want to make sure that my parameters are set. And again, my t should go from 1 to 5. And my u is my rotating variable. My u should go from 0 to 2 pi. And if I click on OK, and then toggle back over into my graph entry. Oh, my goodness gracious. I think I messed that up. I better go check. Oh, I think I have a T in there. That should be a U. Let me double check that. That was a teacher technique. That should be a sine of U, not a sine of T. There you go. That looks better. And so again, I think the next step for the Nspire is to have the capability of exporting this to an STL file so I could 3D print that sucker. But anyway, so if you've not played with the 3D grapher on the Nspire, I hope that you've seen a couple of things tonight that maybe you'd be willing to go into class tomorrow and say, hey, I saw this in a webinar last night, give this a try. again, I think it's having a willingness to try something a little bit differently and just see where it leads you, and it kind of to take the kids just around the corner a little bit from where they are and see what's there. Because again, my kids could do. I've done all of this stuff or variations of this with all of my students. So if I say I've done it with an algebra kid or a geometry kid or a calculus kid, I've done it with those kids, and they can do this. So again, feel free to shoot me an email if you need anything at all, and hopefully you'll come to my session at T-Cube and we'll talk more about this. But Mike, I guess I'll turn it back over to you.
Thanks, Steve. As we begin to wrap things up tonight, if you do have any last-minute questions for Steve, please try to get those asked. I know he'll try to get those questions answered. I want to start by sharing some information on our website, education.ti.com. First, if you're excited about what happened tonight and you want to join us for some other upcoming webinars, if you're not sure where to get those, under the Professional Development tab, near the middle bottom is the Webinars tab. You can slide down to Live T-Cubed Webinars and then Sign Up. And there you'll find a lot of our future upcoming webinars that you can register for. If you happen to miss these, but you decide to register, you automatically get a follow-up email that says, hey, we're sorry you missed it, but here's the recording, the certificate, and the documents. So even if you think you're not going to be able to attend, but you're interested in what the webinar might contain, please feel free to try to register for those, and you'll automatically get follow-up information. So Steve mentioned a bunch of times tonight about this conference that's coming up. It's the T-Cubed International Conference. I think you mentioned it once or twice. And it's exciting. I know someone had mentioned, someone asked a question of you, Steve, that how do you rotate around other lines other than just the X and Y axes? And I don't know, maybe that's a good addition to your T-Cube presentation.
Well, we'll do that.
At T-Cubed?
Yeah, we can give that a try. I don't think it's hard to do.
Nice. So if you want to get a little more information about this T-Cube conference, you can visit our website. But it really is one of the best places I've found to meet with fellow-minded educators, to learn more about technology or content or pedagogy or all three. You get to meet people like Steve and attend sessions where instead of having this short 50-ish minute webinar here, you can actually meet them face-to-face and spend a little more time doing some of this stuff with your own calculator in your own hand, and I think it's a great place to do that kind of stuff. So feel free to visit our website to learn more about the upcoming T-Cubed International Conference in Dallas. And as Steve mentioned at the beginning of the webinar tonight, we're giving away to one lucky winner a T-Cubed International Conference registration. And tonight's lucky winner is Stephanie Givens Chambers. So Stephanie, congratulations. We will be emailing you in a couple of days to give you some more follow-up information about that. But we hope to see Stephanie as well as everyone else at the upcoming T-Cubed International Conference. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we really hope you'll share your thoughts in the post-webinar survey. Feel free to stay connected and continue the conversation that Steve started tonight. Steve, I know you're on Twitter. What's your Twitter handle, Steve?
At GI Ohio.
At GI Ohio. Great.
Don't ask.
Sounds good. So that's, I think, another great place if you have a question, maybe tonight, 3 o'clock in the morning, you're having a dream about this, and you want to ask them a question. It's probably a good place to do that is to reach out to them on Twitter. before I hand out the certificate, one thing I forgot to mention tonight, Kim Thomas, one of our other instructors, is leading a slow chat book study to get people ready for the T-Cubed International Conference. Even if you're not coming to the conference, it can just be a great place to meet other educators on Twitter, speaking of Twitter. So they're all getting the same book this year, and then working from there and sort of reading one chapter a week, and then talking on Twitter throughout that week about things they know, things they wonder. The book this year that they're reading is Blind Spot, Hidden Biases of Good People. It actually started yesterday, January 20th. So if you happen to get that book quickly, you really won't be behind. But feel free to pick up Blind Spot, Hidden Biases of Good People, and join us on a slow chat on Twitter. To receive your certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents from Steve tonight. As these aren't working for any reason, just hang tight. You'll automatically, again, get a follow-up email with a link to the recording, a link to the certificate, and a link to the documents. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Lastly, if you're in need of any post-webinar follow-up, feel free to give us a call at 1-800-TI-CARES or send us an email, ti-cares@ti.com. We'd love to hear from you. So, Steve, thanks so much for sharing everything 3D tonight. This is probably more interaction I've shared in a webinar in a chat window in a while. You got me thinking a lot, and that's always a good thing. So, Steve, thanks so much for sharing everything.
Thanks, guys.
Again, thanks for joining us. We hope to see you back online real soon. Have a great night.